So today I'm going to talk about the population ecology, and I will focus on two aspects: the population growth curves and the K and R selected species. So the first is exponential population growth. So the exponential population growth is population increase under idealized conditions. And under these conditions, the rate of increase is at its maximum, which is denoted as Rmax. So the equation of the exponential population growth is dn dt, and it equals to Rmax times n. So remember, the Rmax is the rate of increase and it's the maximum rate of increase, and n represents the population size. And we can see in this graph, don't forget the x-axis represents the number of generations, and y-axis represents the population size. And as we can see in the exponential population growth curve, it's more like a J-shaped curve. Okay. So, however, the exponential growth cannot be sustained for long in any population. A more realistic population model limits growth by incorporating carrying capacity, which is the maximum population size that the environment can support, which we represent by K. So the carrying capacity varies with the abundance of the limiting resources. And we have the logistic growth curve, and it describes how population grows more slowly as it nears to the carrying capacity K. So in the logistic population growth model, the per capita rate of increase declines as carrying capacity is reached. So we can represent the equation of this curve as dn dt, and it equals to Rmax times n, and here we have the carrying capacity minus population size and divided by carrying capacity. So in this curve, we still have the x-axis as the number of generations and the y-axis as the population size. And the blue curve represents the exponential growth curve, and the red curve represents the logistic growth. And as we can see in the logistic growth curve, we have a more S-shaped, the sigmoid curve, like this. So these two curves are different. Okay, so we are going to talk about R and K selected species. So the K selected species are those species whose the population is near the carrying capacity. So for example, we have birds, mammals, and etc. So, and on the other hand, R selected species is those species that are governed by the maximum reproductive capacity. And we have rodents, insects, for example. And this table summarizes the different characteristics between the R-selected species and K-selected species. So if we look at the maturation time, it's very short for the R species but long for the K species. and the lifespan is short for the R species and long for the K-selective species. The reproductive mortality is very high for the R-selective species but low for the K-selective species. The clutch size for R-selective species is large, and for the K-selective species is very small. And also the timing of the first episode is early for the R-selective species but late for the K-selective species. And the size of offspring is very small for the R species and very large for the K species. So in the R species, they do not need any parental care, but for the K-selective species, the kids will need extensive parental care from their parents.